Perform the division. It looks like there's a lot going on here. But all that's happening is that we're taking that 2x to the fourth on the bottom, and we're dividing each of the top terms by 2x to the fourth. So to do 14x to the sixth minus 14x to the fourth plus 6x squared, all divided by 2x to the fourth, we do 14x to the sixth divided by 2x to the fourth minus 14x to the fourth divided by 2x to the fourth plus 6x squared divided by 2x to the fourth. To divide the powers of x, we subtract the exponents top minus bottom. So 14 divided by 2 is 7, x to the 6 minus 4, minus 14 divided by 2 is 7, x to the 4 minus 4, plus 6 divided by 2 is 3, x to the 2 minus 4, top minus bottom. Subtracting those exponents gives us 7x squared, 6 minus 4 is 2, minus 7x to the 0, 4 minus 4 is 0, plus 3x to the negative 2, 2 minus 4 is negative 2. Now, anything to the 0 power is 1, so x to the 0 is 1, and that x to the negative 2 travels to the bottom, leaving the 3 behind on top, 3 over x to the positive 2, 3 over x squared. And finally, 7 times 1 is 7. So we have 7x squared minus 7 plus 3 over x squared. Number 16, we start to get into factoring now. Did a long stretch on multiplication. Now multiplication the other way, factoring. Not the other way as in another way. The other way as in the other direction. We want to factor out the GCF from the polynomial 32x to the 8th y to the 9th minus 40x to the 5th y to the 6th minus 48x squared y to the 4th. In order to do that, we need to find the greatest common factors of the coefficients, then of the x's, then of the y's. When it comes to the x's and y's, the greatest common factor is simply the lowest power shown. Greatest common factor of 32, 40, and 48 would be 8. 8 times 4, 8 times 5, and 8 times 6. Greatest common factor of x to the 8th, x to the 5th, and x squared is x squared, just the lowest power. Greatest common factor of y to the 9th, y to the 6th, y to the 4th is y to the 4th, again, just the lowest power. Putting those three things together, the GCF of the polynomial is 8x squared y to the 4th. And then we just think about the distributive property in reverse. 8 times what is 32? 8 times 4 is 32. X squared times what is x to the 8th? X to the 6th, because we would add the exponents. Y to the 4th times what is y to the 9th? Y to the 5th, again, because we would add the exponents. 4 plus 5 gives us that 9 in the original problem. And then 8 times negative 5 gives us negative 40. X squared times x cubed gives us x to the 5th. 2 plus 3 is 5. Y to the 4th times y squared gives us y to the 6th. 4 plus 2 is 6. And then finally, 8 times negative 6 would give us the negative 48. And then x squared y to the 4th is all we've got. So there wouldn't be any more x's or any more y's in that third term. So to recap the answer, we have our GCF of 8x squared y to the 4th times our leftover piece of 4x to the 6th y to the 5th minus 5x cubed y squared minus 6. Number 17. Factor the four-term polynomial by grouping. 4xy plus 20x plus 9y plus 45. So we group together the first two terms, 4xy plus 20x. Then since a plus is there, there's no cause for any extra worry. We can just group the second two as is. 9y plus 45. From the first two terms, we can factor out a 4x, which would leave us with y plus 5. 4x times y is 4xy. 4x times positive 5 is plus 20x. From the second two terms, we can take out a 9. 9 times y is 9y. 9 times positive 5 is positive 45. This gives us two terms of two factors each, and we can see that y plus 5 is a factor of both. So we factor out the y plus 5, which leaves us with 4x plus 9 as the other factor. 4x plus 9 times y plus 5. Number 18. We're on a stretch where we're going to factor the trinomial completely, and if the polynomial cannot be factored, we say that it's prime. None of these on the test were prime. They were all able to be factored. In number 18, we have x squared plus x minus 12. We need numbers that multiply to c, and that's negative 12. These same numbers need to add to b. That's positive 1. The numbers that multiply to negative 12 and add to positive 1 are negative 3 and positive 4. Since this is just an x squared trinomial, not a 2x squared or a 3x squared or whatever, we can just write in x and then put in our numbers negative 3 and positive 4. X minus 3 times x plus 4 is our answer. Number 19, we want to factor 2x squared minus x minus 3. This time we have to go about it a little bit differently. Since it's a 2x squared polynomial, our multiplication goal isn't just c, it's a times c. And a times c is 2 times negative 3, which is negative 6. The addition goal is still b. In this example, it is negative 1. So the numbers that multiply to negative 6 and add to negative 1 happen to be negative 3 and positive 2. We use those to split up the middle term. And now we have a four-term polynomial. Instead of minus x, it's minus 3x plus 2x in the middle. We factor by grouping. From the first two terms, we can take out an x. That leaves us with 2x minus 3 left over. From the second two terms, we can't factor anything out, so that's just a plus 1 times the 2x minus 3 that we have. Our process has given us two terms with two factors each, and one of the two factors in each is the same, the 2x minus 3. So we factor that out, and we're left with x plus 1 as our other factor. 2x minus 3 times x plus 1. Number 20. 10z squared plus 11z minus 6. Again, this is a 10z squared. It's not just a z squared. So our multiplication goal is a times c. 10 times negative 6, negative 60. Our addition goal, as always, is b. In this case, that's positive 11. The numbers that multiply to -60 and add to +11 are +15 and -4. We use those numbers to split up the middle term. So instead of 11z, we have 15z minus 4z. And that works because +15z minus 4z is +11z. It's a straight replacement. We've split it up using the numbers we found. And once we have that 4-term polynomial, we can factor by grouping. From the first 2 terms, we can take out a 5z. That leaves us with 2z plus 3 left over. From the second 2 terms, we have to factor out a negative because that's a minus in the middle. So it's not just a 2 we take out, it's a -2. -2 times 2z gives us the -4z. -2 times +3 gives us that -6. 2 terms, 2 factors each. One of the factors is the same in each. That means we're doing a good job. We factor that out, take out the 2z plus 3, and that leaves us with 5z minus 2 as the other factor. Number 21. We have x to the 5th minus 9x to the 4th plus 14x cubed. Don't start off by looking for the multiplication or addition goals, because the unwritten first rule of factoring anything is factor out the GCF first. If there's a greatest common factor, take it out. In this case, the greatest common factor of all those x terms is x cubed, lowest power shown. We take out the x cubed and we're left with x squared plus 9x plus 14. That we can factor our simple way where the multiplication goal is c. We want numbers that multiply to +14 and add to +9. Those numbers are +2 and +7, so we make x plus 2 and x plus 7. Together, the factored form is x cubed times x plus 2 times x plus 7. Number 22. It says here we have a perfect square trinomial to factor. Since it says it's a perfect square trinomial, we can trust it to be one. And we factor something of the form a squared plus 2ab plus b squared as a plus b squared. A is what we're squaring to get 64x squared. That would be 8x. B is what we're squaring to get 49. That would be 7. So we have 8x plus 7 squared. Not minus. It would have to have been minus 112x for it to be the one with minus in it. Number 23. Factor the binomial completely. Here we have a difference of squares. 49x squared minus 64y squared. We can actually square something to get each of those terms. A squared minus b squared factors to a plus b times a minus b. We square 7x to get 49x squared. We square 8y to get 64y squared. That means a is 7x and b is 8y. Put them in the binomials, one add, one subtract. 7x plus 8y times 7x minus 8y. In 24 and 25, we are solving equations, quadratic equations by factoring. So to solve x squared plus 3x minus 28 equals 0, first we need to factor that trinomial. We need numbers that multiply to negative 28 and add to positive 3. Those numbers are plus 7 and minus 4. That is not the answer to the question. Those are just the numbers we use to factor. So we do an x plus 7 and an x minus 4. Times those together equals 0. We use the zero product property to solve this. We have things multiplied together equaling 0. Either the first thing is 0 or the second thing is 0. So we set up x plus 7 equals 0. We set up x minus 4 equals 0. Solving each of these equations, we get x equals negative 7, x equals positive 4. And those are the answers. Finally, number 25. We want to solve we want to solve x times 4x plus 6 equals 4. The first step is to distribute to clear the parentheses. So we distribute the x through the 4x plus 6 and get 4x squared plus 6x equals 4. Then what do? We set equal to 0. Everything on one side, 0 on the other, factor and solve. That's the steps to do these problems. So we move that 4 to the left by subtracting 4 from each side. 4x squared plus 6x minus 4 equals 0. Now we can factor out a 2 and then divide by that 2 to make it go away. 0 divided by 2 is still 0. We now have 2x squared plus 3x minus 2 equals 0. We need to factor the trinomial. We need numbers that multiply to a times c, 2 times negative 2. They need to multiply to negative 4. They need to add to positive 3. Those numbers are negative 1 and positive 4. Use that to split up the middle term. Instead of plus 3x in the middle, now it's negative 1x plus 4x. From the first two terms, we can factor out an x. That leaves us with 2x minus 1. From the second two terms, we can factor out a positive 2, because that's a plus in the middle. That leaves us with 2x minus 1. Two terms, two factors each. One of the factors is the same in both. We like that. We need that. That means we're doing it right. Factor out that 2x minus 1, which leaves us with x plus 2 as the second factor. We have two things multiplied together equaling 0, so set them each equal to 0 and solve. 2x minus 1 equals 0. Means 2x equals 1. Means x is 1/2, positive 1/2. X plus 2 equals 0 means x equals negative 2. So our answers are positive 1/2 and negative 2. We're going to go ahead and do a very short graphing review. And even though this is a review overall, this first problem is something that we may not have covered in the course, but you might be very familiar with already. And that is the concept of a bar graph. This bar graph here shows the expenditures of one city government in a recent year. All the agencies are listed down this left side with bars coming off of them. Across the bottom, it says spending in millions of dollars, and each bar reaches a certain amount of spending. Name the agency whose spending is between $4 million and $5 million. Well, 5 million is right here, so we're looking for a bar that ends between 4 and 5 million. Health comes close, but it passes 5 million. Environment comes close, but it doesn't quite get to 4. All of these are clearly past it. And when we get to the top, fire. Fire ends between 4 and 5. So fire is the agency whose spending is between $4 million and $5 million. So that's just a bar graph. Now we'll get into the more traditional graphing that we worked on earlier in the course. In problem 2 here, we want to identify the intercepts, and this is a visual problem. We're given a graph on the right. That graph has 2 points highlighted, a y-intercept where we cross the y-axis, and an x-intercept where we cross the x-axis. So the points that are the intercept points, the x-intercept would be where the graph touches the x-axis at -1. So -1, 0 is that intercept right here. The y-intercept would be where the graph touches the y-axis. That's at 6. So 0, 6 would be the other intercept point. In problem 3, we want to graph the linear equation -5x minus 30y equals 35. And since the x and the y are on the same side of the equation, we're going to go ahead and use the intercepts method to graph this. To find the x-intercept, we set y equal to 0. When we put 0 in for y in the original equation, that term goes away and we're left with -5x equals 35. Dividing both sides by -5 gives us x equals -7. So the x-intercept is -7, 0. That would be the point. We put that on the graph right here. The y-intercept is where x is 0, so we go ahead and plug 0 in for x. That makes this first term disappear, leaving us with -30y equals 35. Dividing both sides by -30, we get y equals -35/30, which reduces, dividing top and bottom by 5, to -7/6. So the y-intercept is 0, -7/6, and that's -1 1/6. So we go to the graph a little bit past 1 and put our y-intercept there, and then draw the line between the 2 points. In number 4, we want to graph the linear equation x equals -4. Now, the form x equals constant means that the x-axis gets crossed with a straight line. If it was y equals constant, that would be the y-axis getting crossed with a straight line. But since the x-axis is going to get crossed with a straight line, this would be a vertical line through x equals -4. And that's all there is to graphing that. And I said we'd be short. Number 5, our last review problem. Graph the linear equation y equals 5x plus 6. This is in slope-intercept form, y equals mx plus b. And we can match it up and we can see that b is 6 and m is 5. B being 6 tells us that 6 is our y-intercept, the point 0, 6. We put that on the graph right here. Then the slope being 5, positive 5, means that our rise over run is either +5 over +1 or -5 over -1. Minus over minus also gives us a positive number. So that tells us direction. Either we go up 5, right 1, or down 5, left 1. So from our y-intercept, we count up 5, right 1. That would be this point up here. Or from our y-intercept, we count down 5, left 1, which would be this point right here. Either way, we have 2 points now, and we can draw the line through them. That's it. Have you ever been factoring and had the thought cross your mind, there must be an easier way? This short video may be the answer to that question. It may also just confuse you further, in which case ignore it entirely. But I want to introduce a method of factoring called the airplane method. We're not going to get into the name. It has something to do with wings and propellers or something. But before we talk about the airplane method, we're going to very quickly review what our thought process should be when we're told to factor something. So a review of proper factoring. Step 1 of all factoring problems is to see if you can factor out a greatest common factor. That should be the very first thing you always look for. But once you've factored out the GCF, that does not mean that you're done. You get a leftover piece. Or sometimes there is no greatest common factor to factor out, so you're still left with what you started with. And you have to decide, can I factor this further? Now, one of the confusing things about factoring is that we do something completely different if we have 2 terms, 3 terms, or 4 terms. It isn't a one-size-fits-all strategy that we can apply to anything. If it's 2 terms, we check for one of the following 3 situations: a difference of squares, a sum of cubes, or a difference of cubes. So is it in the form a squared minus b squared? Is it in the form a cubed plus b cubed? Is it in the form a cubed minus b cubed? If it is one of those 3 situations, then we use one of the 3 special factoring formulas. For difference of squares, a squared minus b squared, the first thing squared minus the second thing squared, it's the first plus the second times the first minus the second. A and b are the things that we square to get a squared and b squared. With our sum of cubes or our difference of cubes formulas, a and b are the first things and the second things, and we're either adding together their cubes or subtracting their cubes. The formulas I refer to as the SOAP formulas because of the signs: same as the plus, opposite of the plus, always plus. Same as the minus, opposite of the minus, always plus. So if there's 2 terms and it's one of those 3 things, then we use the formula to factor. If it's 2 terms and it's not one of those 3 things, then if we've already taken care of GCF, if we're just looking at the leftover piece, it doesn't factor any further. If we're looking at something to factor and it is 4 terms, we have to see if it's possible to use factoring by grouping. And we're going to review factoring by grouping in just a second, because our 3-term problem sometimes turns into a 4-term problem that we have to use factoring by grouping for. So that's for 2 terms or 4 terms. Primarily, though, we're going to be dealing with 3 terms. We're going to be dealing with trinomials. And we have to ask ourselves, is there a leading coefficient, A, other than 1? If not, then it is case 1, where it's just x squared plus bx plus c. Not a 2x squared or a negative 4x squared or anything like that. Just a plain old x squared or z squared or t squared, whatever our variable is. And that's the quote unquote easy factoring. We find two numbers, number 1 and number 2, such that the multiplication goal is c, including the sign, and the addition goal is b, including the sign. And we set up two sets of parentheses, sized for 2 terms each. X is going to be the first term in each of the parentheses because x times x gives us x squared. And then whatever those two numbers we found were, we put inside the parentheses with the x, plus or minus depending on whether or not the number is positive or whether or not the number is negative. So we include the appropriate signs for each of the numbers. That's the easy form. A lot of people don't have problems with that. But a lot of people then try to use that same strategy on case 2. If there is a leading coefficient a other than 1, if we are in the form ax squared plus bx plus c, where there's a 2x squared or a negative 4x squared or something like that, a 3z squared or a negative 5t squared. In this case, we again find two numbers. This time we're going to call them B1 and B2, though. And you'll see why on the next slide. But these two numbers, B1 and B2, this time we have a different multiplication goal. This time, instead of just C, it's AC. So we have to find AC, or A times C, being careful, again, to include the appropriate signs. The addition goal is still B, including the sign. That part doesn't change. But the big change is that for ax squared plus bx plus c, where a is not 1, we do not set up parentheses. We don't just take the numbers we found and stick them in parentheses with x's. And that makes this a little more difficult. Instead, we take the B1 and the B2 that we found and we use it to split up the middle term. That's why we're calling them B1 and B2. Because instead of plus bx in the middle, we're going to split it with the two numbers that added to be plus b1x plus b2x. And if one or both of the numbers is negative, then we have minus there. Then we use factoring by grouping since we have created a 4-term polynomial. And the way we created it, making sure that it multiplied to a times c, it's going to be a sure thing that we are able to factor it by grouping. So let's take a look at 2x squared minus 7x minus 15. We have to find a times c. That's 2 times negative 15, or negative 30. B is negative 7. So the numbers that multiply to negative 30 and add to negative 7, those are going to be 10, negative 10, and 3, positive 3. It has to be negative 10. It has to be positive 3. That's the only way that it multiplies to negative 30 and adds to negative 7. And we don't just stick negative 10 and positive 3 into parentheses. Since this was an ax squared, we're using those numbers to split the middle term. So instead of minus 7x, we have it as minus 10x plus 3x. And we factor by grouping. Take the first two terms. What can we take out as a GCF? We can take out a 2x. And that leaves us with x minus 5. Looking at the third and fourth term, It's positive, so we take out a positive. We can take out a positive 3. Again, that's going to leave us with x minus 5. We now have a GCF of these two terms of x minus 5, which we can factor out, and we're left with 2x plus 3. So x minus 5 times 2x plus 3, or 2x plus 3 times x minus 5, however you want to write it. Now, that's proper factoring, we'll call it. And notice there's always something to write for work, even if it's just your multiplication and addition goals. And in this class, we do have that rule that we can never write question, then answer, and get full credit. So we have to be able to show some sort of work when we factor. I also want to point out this technically isn't two different things if we take the AC method as the thing we can use all the time. Because what if A was 1? What if we just had x squared plus bx plus c? Well, then A times C would be 1 times C, which would just be C. And that's why in the quote unquote easy factoring method, we just have the multiplication goal of C and not AC. It's because anything times 1 is itself. C times 1 is just C. And factoring by grouping would end up looking just like setting up parentheses and sticking the numbers in. But without a doubt, it's easier when we can just set up parentheses and stick numbers in. And that brings us to the trick. It brings us to the airplane method, because why not? So if we want to factor again 2x squared minus 7x minus 15, we're still going to need B1 and B2 from the AC method. So we still need to find AC. We still need to find two numbers that multiply to AC that add to B. In this case, we needed those numbers that multiplied to negative 30 and added to negative 7. Those numbers were negative 10 and positive 3. So with the airplane method, we start off by setting up parentheses like the easy way. And then we're going to put in 2x and 2x. And we're going to do that because of the 2x squared. And you might be screaming at me at this point. I don't understand much, but I do understand that 2x times 2x is 4x squared. We want it to multiply to 2x squared. So 2x and 2x isn't going to work. Yes, I know it doesn't work. That's why this is called a trick and not something that's actually taught. We're going to take care of it by dividing it down later. But because it's 2x squared, we're going to put in 2x and 2x. And then, when we're doing proper factoring, and I was saying, don't just plug the two numbers into the parentheses. Well, with the airplane method, don't tell anyone. We're just going to plug the two numbers into the parentheses. So now we have 2x minus 10 and 2x plus 3. And here's what makes it all work. We divide by what we can within each parentheses. So 2x minus 10, we can divide both of those numbers by 2, so we do it. 2x plus 3, there's nothing that we can divide both of those by except for 1, but we still, quote unquote, do it. It just won't change anything. But when we divide 2x minus 10 by 2, that gives us x minus 5. And voila, x minus 5 times 2x plus 3 again. So that always works. Yes, as long as you always remember step 1. Factor out your GCF first if there is one. Otherwise, you're going to lose it in the division process at the end. So here's one more example, 24x squared minus 6x minus 9. Step one is going to be to factor out our GCF. We have a GCF here of 3. Factoring out a 3 leaves us with 8x squared minus 2x minus 3. Now, no matter which way we go, we're going to need the AC part of the AC method. We're going to need those two numbers that multiply to AC, that multiply to negative 24 and add to negative 2. Those numbers are negative 6 and positive 4. It has to be a minus 6. It has to be a plus 4. And if we continue down the left, there's proper factoring. Split up the middle term, factor by grouping, get the final factorization, 3 times 4x minus 3 times 2x plus 1. But look what the AC method can split off and do if we go the airplane method route with it. We factored out our 3. That 3 is going to stay in front the entire time through the final answer. Set up our parentheses. We have an 8x squared, so we'll go 8x times 8x. The two numbers we found were negative 6 and positive 4, so plug in the negative 6, plug in the positive 4. 8x minus 6, we can divide both of those by 2, so we do it. 8x plus 4, we can divide both of those by 4, so we do it. And voila, there's our exact same answer. So the airplane method could be another tool if it makes sense for you. Practice it with some of the homework problems. See how you do. At the very least, I hope this cleared up some questions you might have about normal run-of-the-mill factoring.